Hello everyone. Today my topic is Diols alder reaction, second part. Okay. In my earlier videos, I showed to you the Diols alder reaction, and right now I'll do the second videos about Diols alder reaction because the first one was easy one, so I'll give you the little bit hard one, so you can figure out anytime how you can make a using the Diols alder reaction make a ring. Okay. Basically our goal is to make a ring. So for example, if you have anything like think this one 2,4 dimethyl 2,4 dimethyl 2,4 hexadiene react with cyclopentene. 2,4 dimethyl 2,4 hexadiene react with cyclopentene. So look right now, if you want to make a ring, you have to convert the word formula to structure formula. So structure formula is what? There is a hexamine 6. So write the 6 carbon first. 1, 2, 3, 4, 5, 6. Hexamines how many carbon? Hexamine 6 carbon. Okay. So then it's saying number 2 and number 4 position you have a what? Double bond. Give anyone is your number 1. This side or that side it doesn't matter. If you give this side is your number 1, this is number 2. Number 2 second position you have a double bond. 1, 2, 3, 4. Number 4 position you have a double bond. And 2, 4. Then number second position you have a methyl group attached. Substitute is your methyl group CH3. And your 4 position 1, 2, 3, 4. Number 4 position you have again CH3 is attached. Then you fill up the hydrogen. This carbon you don't need any hydrogen. Why? Because this carbon is fill up 1, 2, 3, 4. This carbon has already 4 bond. For this carbon was also the same thing, but this carbon you needed 1 hydrogen. For this carbon you don't need anything because this carbon has already 4 bond. But this carbon you need a 1 more H because this one and this one is 1 hand and 1 H and CH. This carbon needed how many bond? 4 bond. You have a question why this side is you put the number 1, why not this side? Because if you count from that side is also number second position you have a double bond. That's true. But if you count from this side, it's going to be number second position you are getting a substitute. But this side, number second position, you don't have a substitute. So that's why we are counting from left side. Do you understand? 1, 2, second position we are getting our double bond and also we are getting our substitute. So our goal is in the IPF formula, our goal is to make a substitute is in the lower position, and also our functional group, in this case our functional group is double bond, so we are trying to make a double bond is in the lower number. So that's why we did this way, not the other way. So I hope you guys understand I converted from word formula to structure formula anytime. So if you see anytime any kind of word formula, look the last part first. If you see the last part first, draw this one and fill up the carbon bond. If you fill up the carbon bond, you will be fine. Then it's react with what? Then it's react with cyclopentene. Cyclopentene means in the cyclo cases, if there is an alkene, you don't have to mention that one or the position of double bond. Why? Because cyclo cases double bond is always number 1 and 2. So that's why we wrote cyclopentene. Okay, this is the case. Okay, make this one is little bit harder. Instead of cyclopentene, write this one is methyl 1-methyl cyclopentene. 1-methyl cyclopentene. So this is my number 1 CH3, 1 methyl cyclopentane. Okay, good. So right now you have to bend this one. If you don't bend this one, then you cannot make a diols, or then you cannot make a ring. So the difficult part for this reaction is make a bend. I'll show you the technique. Anytime if you see this kind of example in your exam, you can figure out very easily how. Think your bend is going to be like that. Anytime think like that. Okay. Okay, so go to the word formula. Word formula is saying number second position is what? Number second position, you have a double bond. So give this one is the second position, or give this one is the second, it doesn't matter. This one is your second position, so is a double bond. That means this carbon is your number 2. Why? Because it's saying number second position, you have a double bond. So if this one is your number 2, obviously this is your number 3 and this is your number 4. It's saying number 4 position. Look, this is number second, that means this is number third, this is fourth. Number 4th position, you have a also double bond. Okay, right now if it is number 2, that means it start with number 1, right? Start with number 1 means what? That means this is 1, this is 2, this is 3, this is 4. Number okay. Then if it is start with number 4, that means this in here you have a what? This carbon is okay. You need okay. This one is the same. This one, even here is the double bond. Sorry. So 1, 2, 3, 4, 5, 6 is hexadiene, and number second position you have a methyl, and number 4th position you have a methyl. Okay. Then you have a so look right now, you bend this one, right? Then you have to show the how you can make a ring. This one is going to be attack in here. This is motion number 1. When this pi bond is attacking here, there is a too many bond. How many bond is going to be? For this carbon is 1, 2, 3, 4, and if this one is joined, that means 5. But carbon need only 4 bond to fill up. Then this one is going to be coming here. If this one is coming here, there is also too many bond. So what you can do, this one is going to be attached in there. So look right now what happened. This is your cyclopentene. Then this one is joined like that with this carbon. Look, with this carbon. This is my carbon, right? When this one is joined is like that, this one has a CH, and this one is a this C. And look, this carbon and this carbon. But when there was a too many bond, this bond comes in here. When this bond comes in here, this carbon has a too many bond right now. That's why this bond is attacked in there. You see? And this is my thing like that. And this is my methyl. So do you see how I make a ring? Yes, I think you see the how I make a ring. It's not a crazy thing. Why? Because think like that. Think this one is motion number one. When this is attacking here, think like that. I'm jointing. You see how I joined? Yes, I joined in here. When you join this one in here, for this carbon is 1, 2, 1, 2, 3, 4, and if this one is joined here, there will be 5 bond. So that's why this bond comes in here. When this bond comes in here, look, this bond is joined in there for this carbon. For this carbon, there is a 4 bond. 1, 2, 3, 4. Is okay right now. This one when comes in here, for this carbon here is a 1, 2, 3, 4, and if this one comes in here, there is going to be 5. So that's why this bond is joined from here to this carbon. And this CH3 and this CH3 is nothing attached. That's why I wrote exactly how it is. Then you can fill up your carbon. Check every carbon is bond is fill up or not. For this carbon, you see, this carbon is for this carbon is 1, 2, 3. That means there was a hydrogen. You see, 1, 2, 3. That means there was a hydrogen. For this carbon, 1, 2, 3, 4. That means CH3 in there. This is CH3. For this carbon, look, 1, 2, 3. He needed how many more hydrogen? 2 more hydrogen. Look right now. This is your which one? Okay. This one. 1, 2, 3, and there was a hydrogen in there. You see, same thing. There was a hydrogen. For this one, 1, 2, 3, 4. This is fill up. For this carbon is fill up. This is CH3. For this carbon is 1, 2, 3. There is a H1 hydrogen. And this is my methyl group. You see the methyl group still is in there. CH3. And this carbon is a 4 bond. 1, 2, 3, 4. So everything is perfect right now. Do you see? Even if it is crazy molecule, you can make a ring by Diols alder reaction. I hope you guys like my videos. If you like it, don't forget to subscribe and don't forget to share with your friend. If you have any question, you can email me anytime. My email address is alamgirhussain1992@gmail.com. And study hard. Thank you for watching my videos. If you have any question, you can email me. Thank you.